Okay, so for the first video in U-substitution, we want to look at some different integrals and think about how you would find them, or what the problem is with finding them. Now, right now, if you look at this integral, the integral of x e to the x squared dx, you do know a formula, the integral of e to the x dx equals e to the x plus c, but there's more stuff here, right? You have an x squared, you have an x, so there's just more than what you can handle with your basic rules. Same thing here. With this integral, this looks a little bit like x to the 6. You would be able to get the integral of x to the 6th, x to the 7th over 7 plus c, but there's just too much here. You could get an integral of the 5th root of x or the 5th root of y, but again, there's too much. There's a quantity here. And here, I mean, there's just all kinds of problems with this one, right? You have cosine of an angle that's not just a letter, plus you have this in the denominator. So there are a lot of things in these integrals that make them a little bit too complex for the rules that you have right now. So pause if you want to read everything that's on this page. What this all boils down to is if there's too much stuff in the integral, if you can't use your basic integration rules, you have to find a way to rewrite it. What you're going to do is realize that the functions that you're looking at are really compositions of functions. Maybe instead of being able to just integrate the sine x, maybe you have the sine of 5x squared. Well, that's the composition of sine x with 5x squared. So you have to decompose it, you have to pull it apart. And then this is your general rule. Again, pause and write this down, but wait till you see us use it. We'll use it together in the next example, and then this will make all the sense in the world. What you're going to do is try to pick out the inside part, basically, of the composition of the functions, and then its derivative is going to be present in the problem. And you're going to be able to come up with a new way to write the function that does where the basic rules will apply. Okay, so there might be a couple things that you see here that are a problem. I mean, you have a product, and there is no product rule for integration. There's a sum and a difference, but not a product or a quotient. But the biggest problem is that you have a quantity raised to the 5th. So what we're going to do is take what's inside that quantity and call that u. So 1 equals the quantity that's being raised to the 5th. Now thinking ahead, you're going to be able to rewrite this then as u to the 5th, right? And u to the 5th is easy to integrate. All right, now you want to come up with how are you going to change the dx, or how are you going to rewrite the dx? Well, the derivative of this function with respect to x is du dx. But I want you to write du by itself and dx on this side, similar to what we did when we were on our section on differentials. So du is the derivative of 1 minus x to the 4th, and then dx. Okay, well, now let's check out what you have in the problem. You have an x cubed and a dx. Well, looky what you have here. You have an x cubed and a dx. So what I want to do is solve for that, and I can do that by dividing by -4. So that means that x cubed dx is going to get replaced with 1/4, or -1/4, or du over -4. So again, the x dx is going to get replaced with du over -4. And then this was my u, but this looks kind of funny, right? So let's just rewrite things in a normal order, and let's kick the coefficient out, -1/4, and then let's write this part first, u to the 5th du. Now to integrate that is simple, just use your power rule. It's u to the 6th over 6 plus c. It's indefinite, so we go back to using our plus c. And then just make it look a little nicer I'm going to multiply the 4 and the 6. And now for your u, I want to substitute back in what u was. U was 1 minus x to the 4th. That's all raised to the 6th. And then plus your constant. And I would say, and that's it. It's easy. We're done. And it really is easy, and we really are done. But you might want to check it, right? Because if this is my function, then if I differentiate my function, I should get what I started out with in the integral. So remember that to differentiate this function, you would need the chain rule, or the general power rule. So we would bring the 6 down, and 6 times negative 1/24 is negative 6/24, or negative 1/4. This gets raised to the 1 less power. And then you have to multiply, we're in the chain rule, have to multiply by the derivative of this, which is 0 minus 4x cubed. And now you can see when you simplify, the negative plus the, or times the negative becomes positive. Oops, that was the time sign, sorry. And then the 4's cancel out. And you are left with the x cubed and the quantity to the 5th, which is exactly what you started with, so it checks. Now you're done. So I will definitely give you some more examples. There's going to be some more videos going up, but for right now, if you want to get started, if you want to see how many you can do, there's the problems that I suggest you try.